Bismillahirrahmanirrahim. We continue our discussion in software design concepts and principles. This is the second software development phase within software engineering. The first phase that we had already discussed in detail was requirements analysis. During requirements analysis, software engineer collects user demands, user requirements, analyzes the problem that the customer is facing, arrange the requirements according to the needs of customer, and prioritize those which are more important to the customer and helps the most in solving his problem. Requirements analysis generates software requirements specification, which is a document that highlights the complete detailed work of requirements analysis, including the problem investigation, the study of the customer environment, and the demands that have been collected through different requirements elicitation techniques. Generally, three common models are created during requirements analysis phase that include data and information model, in which the categorization of data and the relationship among different data objects is modeled. Then the functional model is developed that highlights the major functions which comes generally from the demands of customer and are converted into a diagram. This diagram is mainly shows the information flow or the function, the data flow among major functions. The third model is the behavioral model that highlights the response of the system to different internal and external stimulus. So three models are mentioned in SRS, which is Software Requirement Specification, and this document is then forwarded to the designing phase. Design phase is further segregated in different sub-design phases, and every individual model that has been generated in the previous phase, which was requirements analysis, goes as an input to one of the sub-design phases. We have started software design concepts and principles and discussed different concepts within software design. In today's discussion, we'll continue our talk within software design and discuss the important software design principles. These principles will help in overall software design. Overall software design means these principles can be applied in all the four sub-design phases. They serve as guideline for the software engineer in preparing best suitable software designs. Let's proceed with today's discussion. In previous lectures, we developed an understanding with the term design, and we said that generally a design is taken as a blueprint or a logical representation of something that is going to be built. Then we developed a relationship between software design and software engineering, how software design is related to software engineering. And as we just said, software design is the second phase in software engineering. Software design then further is segregated in 4 sub-design phases that are the data design, architectural design, interface design, and component level design. Every single sub-phase is carried out by an individual team or an independent team who may not have the expertise to work in other sub-design phase. So the first phase, which was software requirements analysis, that generated 4 models, are then translated into these respective 4 sub-design phases. Then we discussed what is the design process and how we can incorporate quality in software designs. So quality principles have been integrated into the design process, and we had studied those quality principles in detail. Then we had a detailed discussion on these 4 sub-phases of software design, in which we studied first the data design, how data is given a shape and structure in order to be incorporated in the code. So for this, we generally used data structures, different diagrams such as entity relationship diagrams to represent data. Then we discussed the architectural design, and we had seen different architectural styles that are generally given to the data. For example, call and return statement, which is commonly used in programming when you are using the main program who calls subprogram. And similarly, client-server architecture is another common architecture style, along with many other that we have discussed. Third common design subphase is interface design, in which we discussed the user interface design concepts. Though your software may face different elements, so different interfaces has to be designed, such as how your software will interact with other software elements and how it would interact with external environment, and similarly how user will interact your system. So we have discussed the user interface design concepts in this subphase. While the last phase is the component level design, in which we have to design different modules or functions using diagrams. The common design or the common diagram that we used are either you can use the flowcharts or you can use the tabular form. Tabular form is generally used for the applications within artificial intelligence. So these were the points that we have already discussed in the previous lectures. Now let's proceed with today's discussion. In today's discussion, we are going to discuss the main topic of this chapter, which is the design principles. What are the principles that a designer needs to keep in mind while designing a software design. So these principles apply on all these four subphases of design. So whatever level of design you are designing for the software, you need to keep in mind these principles, as these are the guidelines on drawing a better design for the software products. Software design is both a process and a model. The design process is a sequence of steps that enable the designer to describe all aspects of the software that is going to be built. It is important to mention here that the design process is not simply a cookbook. The creative skills, past experience, a sense of what can make a good software, and an overall commitment to the quality are critical success factors for a good design. The design model is equivalent of an architect's plan for a house. It begins by representing the totality of the thing that is going to be built, and slowly refines that thing to provide guidance for constructing every detail. Similarly, the design model that is created for software provides a variety of different views of the computer software. Some basic design principles enable the software engineer to navigate the design process. So these are some of the design principles listed here. The first principle states the design process should not suffer from tunnel vision. This is the first design principle. Now, what does this mean? A good designer should consider alternative approaches, judging every approach based on the requirements of the problem, the resources available to do the job, and the design concepts, which we will be discussing in the coming lectures. So a good designer generally keeps different alternative approaches to design a software, keeping in view different factors such as the resources he has in hand, the problems of the customer, which we have collected in the previous phase. So whatever possible solution can be available to design a better software design should be utilized. He must not focus on one direction only, which will suffer from the tunnel vision. He should consider different alternative approaches. The second design principle states that design should be traceable to the analysis model, because a single element of the design model often traces to multiple requirements. So it is necessary to have a means for tracking how requirements have been satisfied by the design model. So all the requirements should be visible when you design software design. So it is important all the requirements of the user can be seen in the design. The third requirement, or the third principle, states that the design should not reinvent the wheel. Systems are constructed using a set of design patterns, many of which have likely been encountered before. These patterns should always be chosen as an alternative to reinvention. Time is short and resources are limited. Design time should be invested in representing truly new ideas and integrating those patterns that already exist. So, if some of the elements are already available to you through previous projects or some other softwares, you can integrate those components in your design instead of redesigning them. The fourth design principle states design should minimize the intellectual distance between software and problem as it exists in the real world. Now, what does this mean? The structure of the software design should, whenever possible, mimic the structure of the problem domain. That means, in whatever sense user feels the problem or interacts with the problem, in similar manner he should interact with the software so that he could feel that he is using that software in his real world. The fifth design principle is the design should exhibit uniformity and integration. A design is uniform if it appears that one person developed the entire thing. Rules of style and format should be defined for a design team before design work begins. A design is integrated if care is taken in defining interfaces between design components. So your design should represent uniformity. That means only a single team should work in designing particular type of design. Since you have 4 sub-design phases, so a single design phase should be designed by a single team. This will bring uniformity in their work and it will be easy to integrate that particular design in the overall software architecture. The sixth design principle states design should be structured to accommodate change. The design concepts discussed in the previous lectures and the things that we'll be discussing in the coming lectures will enable a design to achieve this rule basically. That means design cannot be complete in one go. This is an iterative process. So user requirements get refined and your design also gets refined in every iteration. So there has to be a room in the design to accommodate change in user requirements. This point or this principle will also help in the maintenance phase. The seventh principle states the design should be structured to degrade gently even when the data, events, or operating conditions are not homogeneous. Well-designed software should never bomb. It should be designed to accommodate unusual circumstances, and if it must terminate processing, do so in a graceful manner. So, if the situation is external or internal environment is not suitable for your software, still your software should be capable to perform its functions. And if it has to degrade, if it has to close, it has to do so in a graceful manner before alerting the user that the system is going to be shut down or the system is going to close. So before closing, user should be given a chance to save all his work. The eighth principle states This is a very important principle. Design is not coding, and coding is not design. Even when detailed procedural designs are created for program components, the level of abstraction of the design model is higher than the source code. The only design decisions made at the coding level address the small implementation details that enable the procedural design to be coded. Design provides a platform for coding, but since, keep in mind, design is not a code. You can get pseudocode through design in shape of algorithms, but still design is not code. And similarly, code is not design. Code shows the complete implementation details of the design. So both are two different things. You can use pseudocode for designs, but code should represent the actual implementation details, how the design is coded using some programming tool. The ninth principle states the design should be assessed for quality as it is being created, not after the fact. A variety of design concepts that we are going to discuss in the coming lectures will help the designer in assessing the software quality. So some of the design concepts that are very important for designing process that we are going to discuss in the coming lectures will help in assessing the quality. And if you remember in the previous lectures as well, we have defined the quality rules for the software designs. 3 quality rules have been defined that we discussed in previous lectures that should be present in your design in order to ensure that the design is of high quality. The last principle states design should be reviewed to minimize the conceptual errors. The conceptual errors are actually the semantic errors. There is sometimes a tendency to focus on small things when the design is reviewed, missing the forest for the trees. A design team should ensure that major conceptual elements of the designs, such as omissions, ambiguity, inconsistency, have been addressed before worrying about the syntax of the design model. Since the design is reviewed by both the developer and the customer, and generally since customer is a layman and not a technical person, so is more concerned about the syntax, how he would use the system. He is mainly concerned about the syntax of the design. Rather, the semantics of the design should be given importance while reviewing the design model. When these design principles are properly applied, the software engineer creates a design that shows both the external and internal quality factors. External quality factors are those properties of the software that can be readily observed by the user. For example, speed, reliability, correctness, usability, etc. While the internal quality factors are of importance to software engineers, they lead to a high quality design from the technical perspective. To achieve the internal quality factors, the designer must understand some basic design concepts, which we are going to discuss in the coming lecture. That is all for now. In today's discussion, we discuss one of the very important topic in this chapter, which is the design principles. These principles actually provide the guidelines to the software designer to design a good quality software design of different levels. Since design is ultimately going to be converted into implementation code, so importance should be given to the design process. And if these principles are applied in different phases at different levels, it is ensured that a good design will be generated, since the success of software is generally dependent on software design. What principles have been discussed in today's lecture? Software design principles are total 10 in number. The first principle states that the design process should not suffer from tunnel vision. That means the designer should not restrict himself to work in just one direction. He should experience alternative routes to form a better design. Second principle states design should be traceable to the analysis model. That means every requirement of the user should be depicted in the design, and it should be easily recognizable within the design. What requirement is implemented in what module should be easily traceable. Third principle states the design should not reinvent the wheel. If you are going to write every module, if we are going to design every module right from the scratch, that will increase the burden on software designer. If some of the module, or if any of the module is already developed earlier in previous projects or is available in some other software, so that should be borrowed and added to the current project, instead of redesigning and spending time, or wasting rather time, on that redesigning of particular module which is already present or available. Fourth principle states the design should minimize the intellectual distance between the software and the problem as it exists in the real world. That means how user see the problem in his real world and how he has to handle or manage that problem in the real world. Software should do the same. Fifth principle states the design should exhibit uniformity and integration. If one team will work on one element of the design, uniformity will be the result, or uniformity will be evident in the software design. Sixth principle states the design should be structured to accommodate change. Change is the main foundation for software maintenance. So design should be flexible. It must accommodate change as user demands keep on changing with the time. Next principle is the design should be structured to degrade gently, even if the condition is not friendly. So if the environment is not friendly for the user, both the internal or external environment, still your software must keep on performing its required functions. Next principle states design is not coding. Coding is not design. Design can have pseudo codes in shape of algorithms, but still that algorithms need to be implemented using some programming tools. So to are different things. Design is separate thing and coding is another thing. Coding is the next phase that we are going to discuss after design. Ninth principle states, the design should be assessed for quality. Quality principles have already been discussed, and we'll be discussing some design concepts in the coming lectures in which quality aspect can be easily assessed for the designs. The 10th principle states the design should be reviewed to minimize the conceptual errors. So instead of focusing on syntax, the focus should be given to the semantics in order to minimize the intellectual distance between the software and the real world. The design model is then reviewed by both the developer and the programmer, which is then signed by both the parties. And this design document or this design model is then proceeded to the developers team, who then implement it using some implementation tools. That is all for now. We'll proceed our discussion with basic and important design concepts in the coming lecture. I thank you all.